How are you, my friends? This is Calculus 1, Lecture 13b, the derivatives of inverse trigonometric functions. This is a continuation of lecture number 13, which I will call 13a. So this is 13b. Let's start. The objectives in this lecture will be the derivatives of the inverse trigonometric functions. We will find the slope of some tangent lines to those graphs, and we will use implicit differentiation. Now, this is a quick review of the inverse sine function. This is the graph. The domain of the inverse sine function will be -1 to 1, and the range -π/2 to π/2 in quadrant 1 and 4. Now, the derivative is what we need here. The derivative of inverse sine of x will be 1 over square root of 1 minus x squared. I will show you the derivation on the next slide. Let's start y equals inverse sine of x. Since this function is 1 to 1, so let's take the sine of both sides. So we will have sine of y is equal to x. Now let's use implicit differentiation on this equation here. The derivative of sine of y, and remember y is a function of x, so it will be cosine of y times y prime is equal to the derivative of x is 1. So directly we can write y prime 1 over cosine of y. Now we know sine squared of y plus cosine squared of y is equal to 1. So we can solve for cosine of y, which is square root of 1 minus sine squared of y. All right, so we can replace that here. So y prime will be the derivative of inverse sine of x will be 1 over square root of 1 minus x squared. Now the second formula is the inverse of cosine function. Same idea here. This is the graph of the inverse cosine function. The domain is -1 to 1, and the range is 0 to pi, which is quadrants 1 and 2. And the derivative of the inverse cosine of x will be -1 divided by square root of 1 minus x squared. Also on the next slide, I will show you the steps, which is very similar to the inverse sine function. You can just go slowly through the steps here. Cosine of y is equal to x. Find the derivative will be minus sine of y times y prime is equal to 1. Y prime will be -1 over sine of y. Sine of y, we can find it from here as square root of 1 minus x squared. So the derivative of inverse cosine of x will be -1 divided by square root of 1 minus x squared. Same idea for inverse tangent. This is the graph of the inverse tangent, and the derivative of the inverse tangent will be 1 over 1 plus x squared. Also, we can see the steps of finding the derivative here. Let y is equal inverse tan of x. Take tan of both sides, will be tan of y is equal to x. Let's use implicit differentiation again. The derivative of tan of y will be secant squared of y times y prime is equal to 1. So y prime will be 1 over secant squared of y. Now we know the formula here from pre-calculus course, 1 plus tan squared of y is equal to secant squared of y. So 1 plus, see here, tan of y is x, so 1 plus x squared is equal to secant squared of x, y, secant squared of y. So 1 over 1 plus x squared. Now this is the summary of all 6 derivatives of the inverse trigonometric function. This is the derivative of inverse sine. This is the derivative of the inverse cosine, inverse tan, the derivative of the inverse cotan, the derivative of the inverse secant, and the derivative of the inverse cosecant. Let's see the chain rule now. If we have inverse sine of u, u is a function of x. It will be the same formula, 1 over square root of 1 minus u squared times the derivative of the u. We have seen so many questions about chain rule, and this applies to all 6 derivatives here. See, like the derivative of inverse cotan of u minus 1 over 1 plus u squared times the derivative of the u prime, which is du over dx. Same thing applies for all these functions. Now let's look at example number 1. Given the function y equals inverse sine of x squared, let's find the derivative dy over dx. We can see here x squared this is u here. So we have to use chain rule. Simple question. So the chain rule here, the derivative inverse sine of u 1 over square root of 1 minus u squared times the derivative of the u. So it will be 1 over square root of 1 minus x squared, that's u, all squared. So u squared, and u itself is x squared, times the derivative of x squared. The derivative of x squared is 2x. Now the final derivative y prime will be 2x divided by square root of 1 minus x to the power 4. Finished. Simple question. Another example, find the derivative of this function. Y equals 10 inverse cosine of inverse sine of x. Now this is u here. You see that? All this inverse sine of x is u. And here's the inverse cosine, and that's a constant outside is the coefficient. Now let's find the derivative. So we need dy over dx. It will be 10. Now the derivative of inverse cosine, we can use this formula here, the first one, chain rule, minus, there is a minus here. So minus 1 over square root of 1 minus u squared, and this is u here, inverse sine of x squared, times the derivative of the u, du over dx will be the derivative of inverse sine of x, which is 1 over square root of x squared. I have wrote the formula here for you to make it easy. Let's simplify everything here to get dy over dx. It will be minus 10, and here we have the product of two radicals. We can put them under one radical. It will be 1 minus x squared in the bracket. Another bracket we have 1 minus inverse of sine of x all squared. That's the derivative. Example number 3, medium question. F of x is equal inverse sine of x divided by inverse cosine of x. Let's find f prime at 0. Okay. If we look at this function here, f of x is equal inverse sine of x divided by inverse cosine of x. We have to remember the quotient rule. The derivative of u over v will be, remember, u prime v minus v prime u divided by v squared. So if I need f prime, it will be the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over all the denominator squared. Now just put the formulas here. The derivative of inverse sine of x will be 1 over square root of 1 minus x squared. You leave that one here, minus the derivative of inverse cosine of x will be minus 1 divided by square root of 1 minus x squared. And there is a minus here. See these two minuses, the same minuses, they will become plus here at the end. We leave this one here, inverse of sine. Now what do I need? F prime, the derivative of the function at 0. So I replace every x by 0 and simplify it. 1 over this, 1 minus 0 squared under the radical, this will be 1. Inverse cosine of 0 will be 90, which is pi over 2. Minus and minus becomes plus. Inverse sine of 0 is 0, so this will be 0. And here we have pi over 2. So pi over 2 divided by pi over 2 squared, we cancel pi over 2. And we are left with 1 over pi over 2. And the answer is 2 over pi. This is f prime at 0. Let's find the slope of the tangent line to the graph. Inverse tan of x plus inverse tan of y is equal pi over 2 at the point 1, 1. Now the derivative here is not easy because we have to use implicit differentiation because y is a function of x. So let's start. Okay. Let's use this formula. The derivative of inverse tan of u 1 over 1 plus u squared times du over dx. So the derivative of the first one is easy, 1 over 1 plus x squared. Inverse tan of y, 1 over 1 plus y squared times the derivative of the y, which is y prime, or dy over dx. The derivative of pi over 2 is 0 because this one is a constant. Now, from this equation here, we have to solve for dy over dx. This is dy over dx. So we can remove this on the other side or remove this on the other side and rearrange it. It will be, you can try it yourself, please. Dy over dx will be minus fraction 1 plus y squared divided by 1 plus x squared. This is the slope formula, dy over dx, which is y prime. So let's find the slope at the point 1, 1. So what do I do? Replace x by 1, replace y by 1, and then you get minus 1 plus 1 squared over 1 plus 1 squared, which is minus 2 over 2, and the slope will be minus 1. Now, this is a nice question. Let the function be inverse tan of exponential e to the power x plus inverse cotan of e to the power minus x. Maybe not easy question. Let's find the derivative. You can try it yourself if you like, and then you can see the answer on the next slide. Okay, we have to use the chain rule. The inverse tan of u, the derivative will be 1 over 1 plus u squared times du over dx. And the derivative of inverse cotan of u, 1 minus, there is a minus 1 over 1 plus u squared du over dx. So let's start with the first one. This is the function f, and this is what we need, f prime. So it will be 1 over 1 plus u squared. Now this exponential e to the power x is the u, times the derivative of u, which is the derivative of e to the power x, plus, there's a plus here in the question. Now the derivative of inverse cotan, there is a minus, you see this minus here, minus 1 over 1 plus u squared, which is e to the power minus x, times the derivative of the u, which is e to the power minus x prime. Now, the derivative of e to the power x is e to the power x, and this one squared, so multiply 2 times x will be e to the power 2x. So the first part is easy, plus. Let's see the second part. There is a minus 1. In the denominator here, we have 1 plus e to the power minus 2x. Leave it now. Find the derivative of e to the power minus x, which is minus e to the power minus x. Now, let's take this in this rectangle here and simplify it on the right side. Only this part, please, after the addition, after the plus. Minus 1 over this times minus e to the power minus x. So when I multiply these two minuses, it becomes e to the power minus x over that. Now, let's make everything positive here. Negative exponent, e to the power minus x, 1 over e to the power x, 1 plus, and this one 1 over e to the power 2x. I add in the denominator here with LCD, e to the power 2x, then I multiply the fraction times the reciprocal. See, I cancel here e to the power x. So what's left on this second part is this, e to the power x divided by e to the power 2x plus 1, which is the same as this. You see, this is exactly the same quantity, like y plus y or m plus m. So the final answer in the derivative will be 2 e to the power x divided by 1 plus e to the power 2x. This is f prime of x. Now, this is the last formula here in this lecture 13b. The derivative of inverse function in general. If we need to find the derivative of an inverse function here at x value, see, the formula will be 1 over f prime of f inverse of x. Why is that? From where we get this formula? Let y, this is a function, let y equal the inverse of f. Now take f on both sides here. F of y will be x. Now this function is 1-to-1. It's given here in the condition. It's 1-to-1 and differentiable. Let's use implicit differentiation. F of y, let's find the derivative now on both sides of this equation. It will be f prime of y times y prime, because y is a function of x, times x prime. See x prime here, the derivative of the x, which is 1. So y prime will be 1 over f prime of y. Now what is y? This is y here, f inverse of x. So y prime will be 1 over f prime of f inverse of x. So just remember this rule here, and remember also the denominator cannot be 0. Let's see here 2 examples on this idea. Example number 6. I have a function here, f of x 1 plus 2x minus x squared for x less than or equal to 1. This is a parabola, and there is a condition here, x less than or equal to 1. So this is 1-to-1 function. Let's find the derivative of the inverse at -2. Let me show you what do we do here. This is what I need, the derivative of the inverse at -2. I can use this formula here. So it will be 1 over f prime of f inverse at -2. I need this value inside the bracket here, f inverse at -2. So what do? So I call it k or m, whatever letter you like. Let this value here inside the bracket, let f inverse of -2 is equal to k. Take f of both sides here. So -2 will be f of k. Now the function is 1-to-1 for sure. F is given 1-to-1. So -2, I leave it here. F of k, I replace k in the function here. 1 plus 2k minus k squared. Then I simplify the equation. This is a quadratic equation. K squared minus 2k minus 3 is equal to 0. I factor it. K minus 3k plus 1. There are 2 values for the k. I check each one. K is equal to 3. Rejected. Why? Because given x less than or equal to 1 and 3 is more than 1, so we cannot accept that. K equals -1. We can accept that. So now k here is -1, you see. So f inverse of -2 is equal to -1. So let's go back to the first line after the given. This is the first line here. F inverse, we need the derivative of f inverse of -2. So it will be 1 over f prime of f inverse of -2. What is f inverse of -2? We have found it's -1. So f prime at -1. So I take the function f, which is given, and find the derivative here. Use this one, the derivative. What is the derivative? Derivative of 1 is 0. The derivative of 2x is 2 minus 2x. So this is the derivative of the function. F prime at -1. I replace here -1. 2 minus 2 times -1. So the derivative of the inverse at -2 is 1 over 4. F is a function. Let's start now again. Now example 7 says f is a 1-to-1 function such that f of 6 is equal to 7 and f prime of 6 is equal to 3. Let's find the derivative of f inverse at 7. Now this example is easier than example number 6. Here directly we go to the formula. We need the derivative of the inverse of this function at 7. So it will be 1 over f prime of f inverse at 7. So we know the function is 1-to-1. It's given, and f of 6 is equal to 7. Let's take the inverse here on both sides. So we put f inverse, f inverse. So 6 is equal to f inverse of 7. So let's go back here to the formula we need. The derivative of the inverse at 7, 1 over f prime of f inverse at 7. F inverse at 7 is 6 from here, you see. So we put 6 inside the bracket. F prime at 6 is already given 3 also in the question. So the answer will be 1/3. Now, always please check the playlist, Calculus 1 solved questions, to learn more about the derivative of the inverse trig functions or the tangent lines or the how to apply implicit differentiation. This is the end of lecture 13B, the continuation of lecture 13A. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.